This demonstration, I would like to draw the tangent line to the curve f of x equals sine of x, and its derivative is cosine of x. And we would like to observe that the tangent lines are going to change their concavity at the inflection points. The inflection points are the points where the second derivative is equal to 0. So, which is uh, from which can be calculated by setting the second derivative equals 0. So let's first I develop develop the graph of sine of x. So I have to take some data points. Start from 0 and with a step size of 0.2. I generate the values of abscissa, and then generate the values of corresponding ordinates from the sine function available in Microsoft Excel. This is the data values. So data has been generated. Now I define the 2 points because the tangent lines are to be drawn by this approximation. A tangent at a point should be computed as the value f of a plus h minus f of x divided by h. This is f of a. So I require 2 points which are close enough. So I define 2 points P and Q. So the x coordinate of point and y coordinate of the point. So for example, any point, for example, the point pi by 2. So the corresponding y value is sine of this pi by 2 radian value. And I define the Q point some h units further from P. So this is P plus the h value. So I'm keeping here h in my control. So to approximate the secant line as a tangent line in a reasonable way, this should be again computed from sine of x. So let's plot the sine of x curve and the secant line from P and Q. So first the secant line. Chart types, select the chart types. Select data and add a series. So x values, P and Q, and y values for P and Q. And I will generate a trend line, a linear trend line, and allow it to extend some units further in the forward direction and in the backward direction. I will also make it solid and with a bright color, and it should be solid so that it is visible clearly all the time. Okay, this is this. So we can see right here the 2 points, and the line is extending in forward direction and in the backward direction. Now, again, the select data option. I add a series, and this is the add a series. This is going to be the actual curve of sine of x, and x value to be selected from column A, and y value to be selected from column B. So at first we see the scatter plot just in the form of points. So I have to change the curve as a solid curve. So curve to be plotted as a solid curve. Okay, this has been done. Now the outline color. Okay, this is fine, and I can choose a rather thick curve, and let me change the scale, set up to 4, and that's it. And for y axis, I would select rather minus 1.1 to plus 1.1, and that's it. Okay. So the curve, the tangent, the secant line is visible, and it is above the curve, and the secant line, which is an approximation to tangent line, it seems to be looking downwards. So it is the negative slope value. And we can have a computation for it, and say slope value is equal to the f of a plus h, which is this value, minus f of a value is at G13, and divided by the h value, so, which is at J dollar 13. So minus 1. Slope value is minus 1. The secant line is looking downwards. So now h value can be reduced, say 0.005. So tangent line, the slope line is still negative. So if I move the point uh, to the left of it, say point, it should be, it is minus 0.05. So we can see the slope value is positive. And if I go some further back, minus 0.5. So clearly the slope value is positive at the before the point P, and after point P, the slope value is positive, is negative. So it means that the slope value has changed around the point P or somewhere close to it. And theoretically, we also know that this is the point of maximum that I can find if I will use this value to say 0.001. So the tangent line seems to be parallel to x-axis, as the slope value uh, is zero for all the practical purposes. So this is the tangent line which is parallel to x-axis. So now see what happens as it crosses the x-axis at the value, theoretically the value pi. So what happens here?